In this module, we cover the oxygen system of the Dash 8 Q400 aircraft. Flight crew and passenger oxygen systems are discussed, followed by the portable oxygen system and protected breathing equipment. The oxygen system is designed to provide oxygen to the flight crew and 10% of the passengers during a 4-minute descent from 25,000 to 14,000 feet and maintained flight at 14,000 feet for 116 minutes. The minimum dispatch pressure for crew oxygen is 1,383 psi or 1,786 psi if an observer is on board in the flight deck. The fixed oxygen system for the flight deck provides oxygen to the pilots and the observer. Each position has a dedicated, full-face oxygen mask equipped with a microphone and an oxygen diluter demand regulator. The portable walk-around oxygen cylinders are kept in the cabin. One is normally located in the forward emergency equipment closet. 3 cylinders are located in the aft draft bulkhead on the right side behind the last seat row. Each bottle is equipped with 3 masks. Protective breathing equipment units are co-located with portable halon fire extinguishers. One is on the flight deck in a compartment on the cabin bulkhead behind the first officer's seat. We now look at the detailed system description of the crew oxygen system. The oxygen cylinder for the flight crew is located in the lower right front equipment compartment and routes oxygen to masks in the cockpit. The oxygen cylinder is a 1.44 cubic meter capacity cylinder. The cylinder is mounted horizontally with the gauge and tubing at the aircraft forward location. The co-pilot's side console incorporates a gauge for the oxygen cylinder pressure. A capillary line from the cylinder feeds to the gauge to display a direct reading. Colored arcs indicate the status of the oxygen bottle. A red arc indicates an under-pressure condition when the pressure inside the cylinder is between 0 and 200 psi. The green arc shows the range of normal operation from 200 to 1,850 psi. Pressure above 1,850 psi is the overpressure caution range, indicated by a yellow arc. The nominal pressure for the cylinder is 1,850 psi. If the internal pressure of the oxygen cylinder exceeds 2,575 to 2,775 psi at 21.1 degrees Celsius, the high-pressure relief valve opens and discharges the oxygen overboard through the green burst disc located on the right side of the nose section of the aircraft. When an overpressure condition occurs and the relief valve opens, the green indicator will be missing. An on-off knob on the oxygen cylinder controls the oxygen flow to the flight deck. When the knob is rotated to the off position, no oxygen pressure is available to the mass. A charging valve allows the cylinder to be refilled. However, the cylinder must be removed from the aircraft in order to be serviced. The oxygen hose from the cylinder to the flight deck is a low-pressure line that distributes oxygen roughly at a pressure of 80 psi. A low-pressure relief valve is installed and opens when the low-pressure line pressure rises above approximately 95 psi. The low-pressure line is attached to the oxygen cylinder by a quick disconnect fitting. The low-pressure hose divides into the left and right sections. The left section incorporates a single outlet valve in the flight deck for use by the pilot. The right section incorporates a dual outlet valve for use by the co-pilot and observer. Three quick downing oxygen masks are mounted on the aft flight deck compartment bulkhead. The masks located outboard are for the pilots, and the inboard mask on the right side is for the observer. Each mask has 3 regulation modes: normal, 100%, and emergency. Normal provides diluter demand oxygen for normal usage, 100% provides 100% oxygen regardless of altitude, and emergency provides 100% positive pressure oxygen. In addition, a microphone is installed into each mask for communications during emergencies. A pressure indicator in the mask hose indicates sufficient oxygen pressure for the mask. A green, inlined pressure indicator in the mask hose indicates sufficient oxygen pressure for the mask. If the indicator is red, the oxygen pressure is insufficient. Let's look at the passenger oxygen system. The passenger oxygen cylinders are located in the passenger cabin draft bulkheads. There is one cylinder in the forward cabin and 3 in the aft cabin. The capacity of each cylinder is 0.311 cubic meter. The oxygen cylinders include a regulator assembly that consists of the on-off valve, fill valve, pressure gauge, and outlet valves. The green on-off switch controls the flow of oxygen from the cylinder to the mass. Placing the switch to the full on position allows oxygen to flow to the mass through the regulator at 70 psi. A pressure gauge on the oxygen cylinder indicates the oxygen pressure inside the cylinder. Normal oxygen pressure is 1,850 psi. The minimum pressure for dispatch is 1,720 psi at 21.1 degrees Celsius. Each cylinder includes 3 masks, allowing oxygen to be supplied to at least 10% of the passengers. The masks are attached to the cylinder's outlet valves with quick disconnect plugs. The maximum flow of oxygen through the outlet valves is 2.1 quarts per minute, or 2 liters per minute at 25,000 feet. A flow indicator in the mask is visible when oxygen is flowing to the mask. We will now look at the portable oxygen system and the protective breathing equipment. Portable oxygen system is used by the flight attendant and provides a portable bottle with a single mask. The bottle is located in the galley and includes a pressure gauge, low pressure relief valve, an on-off valve, and a charging valve. The portable first aid oxygen has both high and low flow outlets, whereas the portable passenger walk-around bottles use only a low flow outlet. Masks are normally connected to the high flow outlet. In addition, protective breathing equipment units are located throughout the aircraft to provide smoke protection and oxygen to the flight crew and passengers. There is one protective breathing equipment unit in the flight compartment, one in the forward passenger cabin, and 2 in the aft passenger cabin. The protective breathing equipment consists of a hood and a chemical oxygen generating unit. When the protective breathing equipment is activated, the oxygen generator releases oxygen into the hood. The oxygen generating unit releases oxygen over a period of 15 minutes as the wearer exhales. The exhaled carbon dioxide and water vapor is mixed with the potassium dioxide in the cylinder to create oxygen, which flows to the hood. The hood of the protective breathing equipment is worn over the head and fits securely around the neck to prevent inhalation of harmful gases and smoke. Green and red lights inside the hood indicate the operation of the protective breathing equipment. A green light indicates the protective breathing equipment is operating properly. A red light flashes along with the green light when the protective breathing equipment is no longer operational and should be removed. The hood also collapses as there is no oxygen flowing. Protective breathing equipment units are stored in metal compartments with metal doors that have a small window to check the seal. The doors are sealed either with plastic breakaway clips or adhesive placard seals. To remove the protective breathing equipment, pull the door from the compartment, remove the sealed pouch, then pull the pull strip to open the pouch. There are dispatch limitations attached to the oxygen system. These limitations are indicated on a placard located below the oxygen cylinder. The limitations for the crew oxygen cylinders are depicted on this chart. There are also limitations for the passenger oxygen system. The passenger portable oxygen bottles must have a minimum of 1,600 psi at 21.1 degrees Celsius of pressure per cylinder. For the first aid oxygen bottles, the limitation is 1,650 psi of pressure per cylinder. This